Hi everyone. Today we will be seeing how to mesh a supersonic or hypersonic scoop in GridPro. The representative scoop has a planar boundary at the top and a semicircular boundary at the bottom. Today we will discuss how we start the topology using a macro closer to the exit region and then extrude it to the front end, address the intake region. The intake region is the most important area. This is a region with high conical flow, that is, gradients are higher near the center and milder at walls. In this video, you will learn how to create blocks by trimming, how to handle overlapping surfaces, and how to improve the quality of the grid. The outer domain of the geometry is a half cylinder. I will use the macro option to create a cylinder topology. Using the measure tool, we can find out the length and radius of the macro to be created. I'm choosing a small domain near the outlet by dropping an insert near the exit and removing the edges at the far end, as it is simpler to define the surface in a smaller domain and extend it further to the other end. This is not a mandate step. If you are comfortable working with a fuller length, you can ignore this step. Group the inner blocks into C1. Let's rescale these inner blocks such that they stay inside the scoop surface. Now we drop inserts to address both the upper and lower scoop surface and reposition them closer to the scoop surface. Ensure the topology resembles the scoop surfaces. You can use the preview option to see if the mesh form defines the shape of the geometry. Now using a work plane, we can move the face till the other outer plane and drop inserts at the inlet of the scoop and a few more near the curve of the scoop. To define the curved surface, we use a trim approach. That's the reason why we split the blocks around that region. Now, let's group the corners which represent the upper and lower scoop surface. Also be careful, at the curved regions, we will have to drop more inserts to form a step-like topology to address the curvature. Similarly, group for lower surfaces also. Towards the tip of the scoop, we can notice both the surfaces overlapping. So at this juncture, the assignments of the scoop lower and upper surface would be overlapping. That is, the assignments of one layer would move into the surface assignments of the other surface. While we take the trim approach, we can notice at the step, two adjacent faces of a block will be assigned to the scoop surface, which will result in a very severe singularity. Before we address this issue, we see there are blocks created in between both the scoop surfaces. So we drop an insert at the edge, connecting both the scoop surfaces, and using an A key, take only the middle sheet and remove the blocks which fall inside the scoop. Being a boundary surface, blocks are to be present only on one side of the surface. Now, coming back to our step topology, we group both the scoop surface assignments into a group and perform a wrap. If your inheritance is in smart inheritance, then by default, the singularity is pushed out into the volume and your topology is valid with no singularities. Check all the surface assignments and using preview, modify your density at required locations. And run grid for a few thousand sweeps. We have loaded the grid. At the tip of the scope, we can see a few singularity points lying at the intersection of both the surfaces. This happens with topologies created using the trim approach. The overlapping assignments end exactly at the trim point. We split the blocks at the trim location and remove the assignment linked to the singularity point. Now let us rerun the grid and load the new grid file. With this, we come to the end of today's tutorial. If you have any questions on the steps or any comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Thank you for watching. If you like this video, leave us a like or subscribe to the channel for new videos. Follow us on our social media pages. The links are posted in the description.